Envision a tremendous troupe played by an unending number of stars, planets, and moons, all performing together eminently. Anyway, there is one explicit piece of this gathering that has confused stargazers for a significant time frame: exoplanets. These are customary planets that exist outside our planetary group, hidden somewhere deep in the Milky Way. You may be astounded to find that among the vast number of cosmic objects, there are exoplanets so like Earth, so tantalizingly similar, yet mysterious, that they may be our planet's celestial twin. Let us delve into the enthralling domain of Proxima b, found just 4.2 light-years away. The James Webb Space Telescope is transforming our journey to comprehend these celestial mysteries. Imagine a moment when your mind ventures across the vast expanse of our universe, the Milky Way, home to more than a quadrillion exoplanets, a number with 15 zeros. To put this into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We have enough to create another landmark on Earth, a Grand Canyon 2.0, extending for an immense distance. Even more astonishingly, around 20% of these heavenly bodies are classified as Earth-like in terms of geography and atmospheric structure. This implies there's a 1 in 5 chance of finding a twin of our planet. But the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our own moon, engaged in a gravitational dance with their parent planets. If you've ever wondered about discovering another celestial body capable of harboring life, the universe offers a torrent of possibilities. Now that we've set the stage for a grand exploration, it's time to introduce the master artist ready to paint its intricate details, the James Webb Space Telescope. This celestial Sherlock Holmes, with its massive primary mirror and advanced optics, surpasses even the most sophisticated optical instruments. Its 6.5-meter mirror is 2.7 times larger than Hubble's, enabling it to detect the faintest glimmer of a star billions of light-years away and analyze the details of surrounding planets. What makes the James Webb Telescope revolutionary is not just its observing power, but also its cutting-edge technology, including advanced sensors and spectrographs. These tools do much more than observe. They analyze and filter the unique light signatures emitted or reflected by celestial objects to determine their chemical composition, density, and even mass. Acting as a cosmic scientist, it can detect water, organic compounds, or even oxygen on a planet. The James Webb Space Telescope elevates our capabilities from mere observation to scientific brilliance. It's not just an improvement over Hubble, it's a quantum leap. If Hubble's discoveries amazed you, prepare for an era of unparalleled revelations as we expand our gaze across the intricate tapestry of the universe. Let's focus on one particular star in this cosmic ensemble, Proxima b. Since its discovery in 2016, this enigmatic planet has stood out as a Shakespearean character, full of complexity and intrigue, captivating astronomers and anthropologists alike. Why is this significant? First, Proxima b is in our cosmic neighborhood, just 4.2 light-years from Earth. To put this in context, if you could break the universal speed limit and travel at the speed of light, you'd arrive in a little over 4 years, about the same time it takes your favorite TV show to cycle through reruns. But let's dive deeper into why this proximity is so critical. We're talking about a universe that spans over 93 billion light-years. Finding a planet so close and so promising for scientific study is like discovering a diamond in a mountain-sized pile, a gem that may hold secrets about life itself. In the grand tapestry of the universe, Proxima b is a vibrant thread offering profound clues that could redefine how we understand habitability and life beyond Earth. What excites scientists isn't just Proxima's closeness to Earth, but also the tantalizing evidence that this planet isn't just Earth-like. It's potentially Earth 2.0. Proxima b comfortably resides in the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, winding rivers, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. However, before we dream of vacations on Proxima b, let's consider some of its unique features. For starters, a single day on this captivating exoplanet lasts a staggering 11 Earth days. Imagine sunrises that usher in a new day slowly, resisting the advance of noon, and sunsets that linger, creating mythical golden hours that photographers crave. While this sounds idyllic, it also has significant implications for its environment and habitability. How would human biological rhythms adapt to such prolonged cycles of light and dark? Would we eat 3 or 4 times as much in a single day? Would we sleep differently? Life, as we know it, would be both tantalizingly familiar and frustratingly alien. Perhaps nature is presenting us with an enigma wrapped in a mystery, challenging our understanding of what makes a planet habitable. How do we gather precise and reliable data about a world we've never visited? The James Webb Space Telescope employs its capabilities like a giant Swiss Army knife. It's more than just a telescope, it's a state-of-the-art laboratory operating in the vacuum of space. Thanks to its innovative technology, astronomers don't just observe planets, they analyze them through a prism of scientific instruments that make even advanced terrestrial laboratories look basic. Using advanced spectrographs, the telescope studies the light emitted and reflected by these distant worlds. Every element or compound in a planet's atmosphere absorbs or emits light at specific frequencies. By examining these patterns, scientists perform a remote biopsy of celestial bodies, determining atmospheric pressure, density, and the possible presence of life-supporting compounds like water, organic carbon molecules, and even oxygen. This isn't just astronomy, it's space forensics. Scientists don't passively wait for clues to come to them. They actively seek them, dissecting the particles and molecules that compose these complex worlds. The James Webb Space Telescope isn't merely an eye in the sky, it's an exceptionally specialized scientific marvel. As we refine our techniques and delve deeper into the universe, the James Webb Telescope continues to unlock mysteries from Proxima b and beyond. The data it gathers has the potential to reshape our understanding of habitability, atmospheric composition, and the conditions that foster life. Returning to Proxima b, one of the most fascinating aspects of this exoplanet is its position around its parent star, Proxima Centauri, a red dwarf. Unlike our Sun, red dwarfs are smaller, cooler, and dimmer, making their habitable zones much closer to the star. This proximity raises critical questions about Proxima b's environment. The planet is likely tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. This creates extreme temperature differences between the two hemispheres. However, if Proxima b has a sufficiently dense atmosphere to distribute heat, its twilight zone, the region between the light and dark sides, might be temperate and capable of supporting life. But Proxima Centauri isn't without its challenges. Red dwarfs are notorious for their stellar flares, which can emit bursts of radiation powerful enough to strip a planet's atmosphere over time. Nevertheless, scientists speculate that Proxima b may have a strong magnetic field or other protective features that shield it from these effects. This is one of the critical questions the James Webb Telescope aims to answer. In addition to studying atmospheric conditions, researchers are also searching for biosignatures, signs of life. The presence of gases like methane, oxygen, or ozone in specific ratios could indicate biological activity. Spectral analysis of Proxima b's atmosphere will provide crucial clues, offering us a chance to answer the age-old question: are we alone in the universe? The journey doesn't stop with Proxima b. The James Webb Telescope is a gateway to exploring countless other exoplanets scattered across the galaxy. From super-Earths with vast oceans to gas giants with moon systems that could harbor life, the telescope is redefining the boundaries of human curiosity and capability. As we gather more data, humanity stands on the cusp of a new era in space exploration. Proxima b is just the beginning, a stepping stone in our quest to understand the universe and our place within it. Imagine a future where we identify planets not just as distant objects but as worlds with weather patterns, ecosystems, and perhaps even civilizations. The implications for science, philosophy, and humanity as a whole are profound. The discoveries made by the James Webb Telescope are not merely about distant planets. They are reflections of our own drive to explore, to question, and to seek understanding. Every revelation brings us closer to answering some of the most profound questions. How rare is life? What conditions are necessary for it to thrive? And most importantly, what does it mean to be a part of this vast, interconnected universe? In this new age of discovery, we move beyond speculation into a realm of tangible possibilities, where dreams of interstellar exploration and understanding are within reach. Proxima b and the James Webb Telescope represent not just a leap in technology, but a leap in our collective imagination, a journey toward uncovering the secrets of the cosmos and, perhaps, finding a mirror to our own existence among the stars. Techniques to confirm or invalidate them disturb our understanding of what could exist beyond our blue spot. Just at the point when you assumed you had uncovered the most shocking layers of this cosmic onion, the story veers off in a strange direction, similar to a sci-fi thrill ride. Specialists using the James Webb Space Telescope found something surprising from Proxima b, a transmission so unprecedented that it spread through scholarly circles and online platforms. Named a potential technosignature, it was an electromagnetic discharge so complex and intentionally designed that it hinted at the presence of an advanced civilization. The collective heartbeat of humankind seemed to pause at the pinnacle of a discovery that promised to reshape our perspective on reality. Could this transmission be definitive proof that we are not alone in the universe? Yet, as quickly as it appeared, the transmission vanished, leaving behind a profound silence and a maze of unanswered questions. Was it simply a transient celestial phenomenon, a cosmic coincidence, or something else? Intentional, perhaps a coded message or a sign of extraterrestrial intelligence. This singular signal cast a shadow of mystery over Proxima b, igniting extraordinary discussions and hypotheses. Was it merely a fleeting anomaly, or part of a far grander, more intricate narrative than we can imagine? The incomplete astronomical account, however, remains. Pause. The tale of our cosmic exploration is far from over. The ink has not yet dried, and new chapters are still being written. This time, it's not just conventional investigators, but also Harvard scientists leading a paradigm shift in our search for extraterrestrial life. They are not content with merely analyzing the transmission or the phenomena observed so far. Instead, they are raising the stakes by transforming the James Webb Space Telescope into a kind of giant night vision telescope. Their aim is to search for artificial light sources in both the dark and illuminated regions of distant universes. Take a moment to consider the dazzling possibility of detecting the cosmic equivalent of cities glowing in the dark like brilliant sparks of civilization. Picture beams of light from a bustling city transmitting its radiance into the vast cosmic oceans. As we continue unraveling the universe's mysteries, the search for extraterrestrial life takes on new dimensions. Beyond Proxima b, our grand quest delves deeper into the expansive, unknown regions of space. This pursuit is driven by technological advancements and a profound curiosity about our place in the cosmos. The search for life beyond Earth has been fueled by constant breakthroughs in astronomy and space exploration, leading to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, JWST, biomarkers, and ground-based observatories have enhanced our ability to identify and study these distant worlds. One particularly captivating area of research is the search for biosignatures, signs of biological activity. These may include atmospheric gases, such as methane or carbon dioxide, which, under the right conditions, could indicate biological processes. The JWST's advanced capabilities extend beyond simple detection. Its sophisticated instruments can analyze the atmospheric composition of exoplanets with remarkable precision. By studying starlight filtered through an exoplanet's atmosphere, researchers can identify chemical markers indicative of life. For instance, the presence of water vapor alongside key molecules like oxygen or ozone could suggest life-supporting conditions. Another avenue of research involves studying the environments of these distant worlds. Climate models, based on data from the JWST, help predict whether an exoplanet's conditions could support liquid water, a crucial ingredient for life as we know it. Scientists are particularly interested in planets located in the habitable zones of their parent stars, where temperatures could allow for stable liquid water. The search also extends to the moons of exoplanets. Some moons, especially those within the habitable zones of their host planets, could harbor conditions suitable for life. For example, icy moons in our solar system, such as Europa and Enceladus, are thought to contain subsurface oceans beneath their frozen crusts. Similarly, moons orbiting exoplanets might present comparable conditions where life could exist. Technosignatures and advanced civilizations. The concept of technosignatures has also gained traction. These are indicators of advanced civilizations that might be detectable through artificial structures or technologies. Examples include megastructures like Dyson spheres, hypothetical constructs designed to harness a star's energy, or peculiar patterns in radio transmissions. As global collaborations and observational techniques advance, the search for technosignatures could unveil the presence of extraterrestrial intelligence. Global collaboration and public engagement. In addition to technological progress, global collaboration plays a critical role in the search for extraterrestrial life. Partnerships among space agencies, research institutions, and private organizations enhance our ability to explore space. For instance, missions to Mars and other celestial bodies involve contributions from multiple nations, pooling resources and expertise to achieve shared objectives. Public engagement and education are also essential. The excitement surrounding space exploration inspires the next generation of scientists and engineers. Outreach programs and educational initiatives foster interest in STEM fields, encouraging young minds to pursue careers in space science. Future exploration. The development of new technologies further deepens our understanding of the universe. Advances in telescope design, data processing, and computational modeling improve our ability to detect and study distant exoplanets. For example, next-generation space telescopes like the planned Extremely Large Telescope, YELT, and the Habitable Exoplanet Observatory, HABEX, promise even more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each new discovery raises new questions and avenues for exploration. The search for extraterrestrial life is not just about finding alien civilizations. It is also about understanding the origins and potential diversity of life in the universe. This pursuit challenges our perceptions and broadens our understanding of existence itself. Beyond habitability. While much of the focus has been on finding Earth-like conditions, researchers are expanding their scope to include environments vastly different from our own. Life, as we know it, relies on water and carbon-based chemistry. But what if alien organisms use entirely different biochemistries? For example, life could exist in environments with liquid methane or ammonia instead of water. Some researchers are even exploring the possibility of silicon-based organisms or entities thriving under extreme conditions, such as the immense pressures of gas giants or the intense radiation around neutron stars. These considerations remind us that our understanding of life is limited by our terrestrial experiences. To truly grasp the possibilities of extraterrestrial life, we must remain open to the idea that alien biology might challenge everything we think we know about existence. Planning for the future. Interstellar exploration. The next frontier in the search for life lies in interstellar exploration. While current missions focus on our solar system and nearby exoplanets, future technologies may enable us to reach distant stars. Concepts such as light sails, nuclear propulsion, and even warp drives are being explored as potential methods to achieve interstellar travel. One particularly ambitious idea is the breakthrough Starshot project, which aims to send a fleet of small, light-propelled spacecraft to the Alpha Centauri system. If successful, this mission could provide unprecedented insights into distant worlds and their potential for hosting life. Citizen science and public participation. As the search for extraterrestrial life becomes increasingly accessible, citizen scientists are playing a vital role in expanding the scope of research. Platforms like SETI at Home allow individuals to contribute computing power to analyze data for unusual signals. Publicly available datasets from missions like Kepler and TESS also enable amateur astronomers to search for exoplanets and other phenomena. Engaging the public in these endeavors not only democratizes science, but also fosters a global sense of curiosity and wonder. Educational initiatives, science fiction media, and open access research are inspiring a new generation of thinkers and visionaries to participate in humanity's cosmic journey.